Hey everyone, so this lesson is the quotient rule. So earlier our previous lesson was all about the product rule, what happens if functions are multiplying. Today it's all about what happens if we are having functions that are being divided. So pause the video and do the do now. So an equation of the normal line to the graph of g of x at the point where x equals -2. So we need that y value. So I'm going to start by plugging in -2. That's -8 plus 8 plus 4 plus 1. So my y value is 5. And then I need the tangent line to find, or the slope of the tangent line. So to find the slope, we take the derivative, 3x squared plus 4x minus 2, and then I'm going to plug in that -2 again. So that's what? 412 minus 8 minus 2. So I get 10. No, that's just, I get 12 minus 10, which gives me 2. So if 2 is the slope of the tangent line, so the slope of the normal line would be -1/2. Now this one's slightly annoying because normally I can just write, oh, y minus 5 equals -1/2 x plus 2 and be done with it. But that's not going to work here because I have to write it in standard form. So I'm going to multiply everything by 2. Or -2, it doesn't really matter. I'm going to do 2. Let's see what happens there. So that gives me 2y minus 10 equals -1x plus 2. So 2y minus 10 equals -x minus 2, x plus 2y. I move that to the other side, and then I move the 10 over and I get 8. So x plus 2y equals 8, d. All right, now this one you really need to look at graphically. There's not a good way to do these otherwise. So if I were to graph this, it's a v because it's an absolute value. So the question is, where's the v? It's right 4, up 1. So what's the derivative of this at 4? Well, because there's a corner, it does not exist. Now, you really do have to pay attention because if I said f of 3, if it was f of 3, this would be the point. That would be a slope of just -1, the slope of the line. So you got to be careful and really pay attention to the point. Is it the actual corner? Is it just another point? So pay attention to what they're asking, the area that they're asking for. Okay, so similar to the earlier lesson, I keep saying yesterday, it wasn't actually yesterday, it was earlier. I want you to find the derivative of each of these. So f prime is 5, g prime is 30x squared, and h prime is 4x. So now if we take g over x, right, g over f, that gives me 10x cubed over 5x, which is 2x squared. So if we divide f in number 1 and number 2, it gives us number 3. If we divide their derivatives, what's g prime of x divided by f prime of x? That gives us 30x squared over 5, which is 6x squared. 6x squared and 4x are different. So you can't just find the derivative of each of them individually and divide. It doesn't work like that. It's more complicated. So this one is more complicated because it's division than the last one. So be ready for it. So just like always, we're taking our function and we're using f over g and we're plugging into the different quotient, right? So f of x plus h minus f of x all over h. So we have these fractions this time. And think about it. What do we always do every single time when we have a fraction? We always just find the common denominator, right? So on this left side, we multiply by g of x on the bottom and the top. Right? So that's how we get that. Over here, we multiply by g of x plus h, g of x plus h, and that gives us this. And then we've talked about this a bunch of times. If you have like 2/3 divided by 5, divided by 2/3 is the same as multiplying by a fifth. So you end up just multiplying those together. So this h ends up just going in the denominator. So that's how I get this bottom piece. So now, just like in the earlier one with the product rule, we're going to do the mathematicians are brilliant, and they come up with these weird things, and I don't know how they come up with it. So then they're going to add and subtract something into this function. So this time, they're adding and subtracting f of x, g of x into the problem, right? So they subtracted it and then added it. And then again, just like before, we're going to break it up. So we're going to put these together. And because it's division with pluses in there, the denominator is going to go with both of them. So we have that one, and then we have this one. Okay? So now notice, it's in green, the minus. We end up switching the order. We want the g of x plus h and f of x to go first. So this goes out front, and that changes the sign of the g of x. Okay? So we're factoring out f of x. We're actually, think of it as factoring out a negative f of x. If I factor out negative f of x here, right, this becomes the g of x plus h is positive, and this f, sorry, we're factoring out the f, the g is negative. So that's kind of a weird thing that happens here. Over here, we're factoring out the g of x, so it's f of x plus h, f of x. All right, so this isn't so pretty, right? But it's a similar idea to the one we did yesterday. Okay, so now let's look at what they did. So this is the exact same thing from the previous one. Okay, so now what we're going to do is we are breaking this up. Notice we have f of x plus h and f of x. I think that looks familiar. So if I'm basically going to take this part and create its own like thing, right? F of x plus h minus f of x all over h. So I'm kind of breaking those denominators apart here. Right? So this, I'm taking this g of x plus h and making it into its own denominator. And then the same thing over here. We're going to put the g's and the h's together. And then bring that to the denominator. So if you notice what we have here, we have our g of x times, this is our definition of the derivative, right? That's your g prime. That's our f prime. Just kidding, because that has f's in it. And then over here we have our f of x, and this time we have our g prime. So just like that last one, but then we have this crazy denominator thing happening. We have g of x and g of x plus h. So when we take the limit, we get g of x squared. So, but we notice this time we have two separate fractions, so we're going to put those together. So it's really, really similar to the last one, g of x f prime minus g prime f all over g. So I think of this, and the original problem was f over g. So this one, the order is important, right? Derivative of I actually usually write this backwards. I write f prime g minus g prime f. So derivative of the first times the second, derivative of the top, times the bottom, minus derivative of the bottom times the top, all over the bottom squared. Notice that's g of x squared. Okay. So derivative of the top times the bottom, minus top, derivative of the bottom, over the bottom squared. There's this fun like little tongue twister. If you think of it as low over the high over low. Wow, my brain right now, man. Like the top is the high and the bottom is the low. And then the d is derivative. So it's low d high, so the low times the derivative of the high, minus high d low, the top times the derivative of the bottom, over low, the bottom squared. So low d high minus high d low over low. It's just kind of a fun tongue twister that's common for teachers to teach. All right, so I'm going to write the derivative here. So h prime, so it's f prime g minus f g prime all over g squared. So it's basically the product rule with a minus and then the bottom squared. All right, so why does it not? Why are you moving? Stop moving. All right, f, no, stop it. F prime, there we go. All right, so this is my f, this is my g. So the derivative of the top is e times the bottom, 3x plus 2, minus the top, derivative of the bottom, it's just 3, all over the bottom squared. So this is a good one just because there's really not anything, another way to do it. Like, you have to do the quotient rule here. There's no trick for this one. Same with this next one. There's not really a trick here. The answer's kind of obnoxious because the derivative of the top is 1, the derivative of the bottom is 1. So your answer can be simplified pretty well, but there's not like a big trick here. Derivative of the top is 1, so 1 times the bottom minus the top, derivative of the bottom over the bottom squared. Like, you can't do anything. You do get kind of a nice, if you decided to simplify, that top becomes x minus 1 minus x minus 1. So the x's cancel, so you get negative 2 over x minus 1 squared, if you want to simplify it, which is kind of nice. It's a nice, easy answer. All right, pause the video and try 3 and 4 on your own. All right, so g prime, derivative of the top, 14x minus 3 times the bottom, x to the 5th, minus 12x squared, minus the top, 7x squared minus 3x plus 2, derivative of the bottom, 5x to the 4th, minus 24x, all over the bottom squared. I'm begging you, don't simplify that. Grading these are super annoying. It's really hard to grade these. Please don't simplify. It makes it so much harder on me. Unless you just feel the need to torture me because I like to torture you. Please leave them like that. Okay, it drives me up the wall when kids use a quotient rule for this. There's no reason to use a quotient rule. This is x to the negative 3. If you did the quotient rule, it works, but it's silly. G prime is negative 3 x to the negative 4, which is negative 3 over x to the 4th. The derivative of the top is 0. Anytime the derivative of the top is 0, don't do a quotient rule. It's too much work. That's silly. It's just silly. Don't do that. All right, now we're getting into the tricky ones. All right, so I want you to pause because notice the derivative of the top in both of these. The derivative of the top is a product rule. So you have to do a product rule within a quotient rule. And I'm telling you right now, I will put this on your next test because I want you to be able to do this. All right, pause it, try it on your own, write neatly, write slowly because it's a lot. All right, I'm going to color code. All right, so that bottom is blue, top first is red, top second is green. Okay, so the derivative of the top is a product rule. So I'm going to do I'm starting my product rule. 4x cubed e to the x plus, now the derivative of the second, x to the 4th e to the x. That's the entire derivative of the top. So that whole thing then has to get multiplied by the bottom. Oops. 2 and 3 are not the same number. Negative 2x plus 8. That entire thing is the derivative of the top times the bottom minus the top, x to the fourth, e to the x, times the derivative of the bottom, all over the bottom squared. And you really should put f prime somewhere. All right, that's the first one. Wasn't that bad. All right, next one. Again, we're going to start off with that product rule. The derivative of the first, 8x minus 3 times the second, 9 minus x, plus, again, product rule, the first, 4x squared minus 3x plus 9, derivative of the second, negative 1, right? The derivative of that is negative 1. That entire thing is the derivative of the top. So for our quotient rule, derivative of the top times the bottom minus the top, I'm just going to rewrite all of that really tiny because I'm running out of space, times the derivative of the bottom. Derivative of the bottom is just 10 e to the x all over the bottom squared. And that's it. Yes, it's gross. Again, we're not simplifying. We're going to leave that exactly as it is. Okay, that's it. That's done. We're done with the quotient rule. So now I just want to have you write down some notation. So I talked about this briefly in one of our classes. There are two different derivative notations we use. This notation, which we've been using, the other is dy dx. It's just another way of representing the derivative. So dy dx or d dx of f of x. So we're going to get into second derivatives, third derivatives, and it's common for second derivatives to use this. It's just another way of writing it. So you will see more than one. You will see all of these. All right. Find the second, third, and fourth derivative. So we have to find them all, right? So g prime, what's the first derivative? 6x squared. So then the second derivative. So now we're just going to do the derivative again. 12x, that's the second. Third derivative, 12. Fourth derivative, 0. What would be the seventh derivative? 0. Once you hit 0, it's just going to go on and on and on. Ooh, this one looks fun. All right, pause it. And find the first derivative first. All right, so I get 2x e to the x plus 1 plus x squared e to the x. I feel like it would have been easier to distribute first, but I've already committed. All right, that's my first derivative. Now second derivative. So now I have to do a product rule with that. So do the product rule there. Derivative of the first times the second plus the first derivative of the second. And then I have to do a product rule here. Derivative of the first times the second plus the first derivative of the second. Now these are complicated because you have, sorry, my brain stopped working there for a minute, because the e to the x's never go away like in the previous one. Now at this point I would simplify this. Like I said, you don't have to simplify, but if you notice 2e to the x, 2e to the x is 4e to the x. So what we really have here is 2e to the x plus 4x e to the x. And then we have our 1 plus x squared e to the x. Which actually, if you distribute that through, you can simplify a little bit more. But I'm going to leave it. All right, and then the third derivative. So 2e to the x. Derivative of 4x is 4 e to the x plus, leave the 4x. Derivative of the first, 2x. leave it alone. Derivative of e to the x, z to the x. So these will go on forever. Like you'll never stop if you just keep going, and you can just go through it forever. So yeah, I think this one would have been easier if we went through and distributed to start and just did e to the x plus x squared e to the x. I think it would have been easier if we did it like that instead of having the 1 plus. It wouldn't have been a huge difference in the end, but I think simplifying would have been a little easier. All right, and that's the lesson. So quotient rule, finding second derivative, third derivative, forever derivative, it happens. All right, so 20 through 56 even. Again, this is just drill and kill. Just get used to these processes. Have a fabulous day.